LeetCode 805 split array with same average. So this problem states that we are given an integer array nums and we should move each element of num into one of two arrays A and B such that A and B are non-empty and average of A is equal to average of B, right? And return true if that is possible. If not, then we need to return false otherwise. So let's suppose we take this example only 1, 2, 3, 4. And so it's in subset 1 and in subset 2, basically two parts. Here it's not necessary that suppose this total length is n, that it should be of equal length. Suppose this contain A elements and this contain B elements. They can be equal and they also cannot be equal. Both are possible here. And we need to find the average of this and average formed by these subsets by picking these P elements and by picking A this element. Suppose the average formed by picking these A elements is like something like AVJ1 and here is suppose like AVJ2. So this should be equal. And as we all know what the average is, average simply means the sum of all the elements by total number of elements present. Right, this is what average is. So from question, if we can say, suppose in subset 1 we pick 1, 2, 3. So subset 2 we need to pick rest of the elements, right? 4, 5, 6, 7, 8 and 9. You need to find the sum and find the average, and that should be equal. It's not necessary that both should contain equal number of elements, but one condition they have given here, if you see, both A and B are not empty, right? They should be non-empty. What by mean that we can't pick something like subset A is empty, we didn't pick any element, and in subset 2 we picked all the n elements. Also in subset 1 we pick all n elements, and in subset 2 we pick 0 element, right? Nothing we pick. So this case is not possible. So this is what question is asking. So if we try to mathematically derive this, what they're actually asking, suppose we have picked two, we have make two subset 1, subset 2, we have found their sum. Suppose this sum is sum 1 and this sum is sum 2, and the number of elements here are n and here suppose are m. So it should be equal. That is what simply question is asking, right? So can we write like this, sum 1 and sum 2 can be written something like this, right? Total sum of the array, this is what, minus sum 1, right? And this is the total count, t is the total count, and this is n. We can write like this totally. So if you solve this, like we can solve it using, if you solve this, we reach something like this. Let's suppose if we like mathematically derive this. So suppose if we solve this mathematically, so what it will give us, sum 1 into t minus sum 1 into n, and is the total sum capital S into n minus sum 1 into n, right? This n. So this get crossed and utilized, and what we left with sum1 equal to total sum into n by t. Right. What is t? T is the total count, n is the number of elements present in sum1, and this is the total sum. So from two subset we have reduced it to one subset, because forming two subset is somewhat more tricky. So better in this type of problems we make it somewhat to move to one subset, because forming one subset is much more easier, right? So we have reduced our problem to this, something like this: sum1 equal to sum1 into n by t. We can also say from here that sum1 by n equal to total sum by t. So what is this? This is the average of the subset, that one subset we have chosen, and this is the total average of the whole array, total average of whole array. So we can see that average of A equal to total average of A. So the subset we choose, that average should be equal to the total average. This is what our final problems to boil down to, this condition, right? So now this is our subset 1 that we have chosen. This is our subset sum, basically. This is subset sum 1. This is the total sum. This is the number of elements present in subset sum 1, and this is the total number of elements present. Now can we say something like this, that and also, so can anytime this can be empty? No, right? I mean, the number of elements present in S1 can never be 0, and also n can never be, number of elements present can never be the total number of elements, right? Why? Because if we have included all the elements in S1 only, then S2 will have no element left, right? And if we take 0 element, then S2 will have all the elements. That is also not correct. So we try to avoid this condition. So here this is the total number of elements in S1. So two conditions we have derived, that total number of elements cannot be 0, and total number of elements cannot be the total number of elements, like the whole array elements, the size of the actual array. Now what we need to do, we are actually forming all the subsets, right? That's how we will make it equal, right? We need to check this condition. So what we will do, we will form all the subset for someone, like suppose 1, 2, 3 and 4 is given our array. So we will form all the subset of these 4 elements, and we will sum them, and we will try to make it equal to sum n by 2. If this condition satisfies, then we got our answer. But if we see here how much subset we can form by using these 4 elements, it will be 2 to the power 4, right? And if we go our condition constraint, we can see 30. So max what we can get in the worst case scenario, how much element can be present? It can be present 30 elements, right? So how much subsets we will end up with? 2 to the power 30, because we need to check each and every subset, right? Which is a very large number of elements, right? Very large, and also not very optimal. So what we can do instead what we can do, we can divide this into 2 halves. The subset 1 will be the left half and what will the right half. By dividing, what I means, let's suppose our original array was 1, 2, 3 and 4. We will divide this into two halves, right? One half will contain half of the elements and other half will contain half of the elements. This is in case of even length. Suppose there are odd length present, then obviously then again we will derive, like we will divide here. This will become one half and this will become another half. So by this, if you see, and we will try to form the subset individually, like for first half 1 and 2 will be our one array, another array will be our 3, 4 and 5. So we will try to form the subset of these. So how much we get, like suppose if this was our main array 1, 2, 3, 4, 5, if we form all the subset of this, so we will get something around 2 to the power 5. And if we form this, then we will get 2 to the power 2, and here we will get 2 to the power 3 subsets, right? So which is 2 to the power 2, 4, and this is 8. So we need to form 8 plus 4, 12, right? And if we form 2 to the power 5, then how much we need to form, right? We form around 32 subsets, right? So we can see that this is much more optimal than this forming this whole. So this is a main reason that we divide this into two halves, so that our subset number of subset form that we form get reduced. So now since we have divided this S1 is 1, 2, 3, 4, 5 as of now into two halves, left half and right half. Left half will contain 1, 2 and right half will contain 3, 4, 5. We try to generate all the subset of these. We need to find their sum along with the length. By length, what I mean, since here we are finding the average, right? So the subset sum will not be enough. We need to deal with average here. So obviously the number of elements responsible to form that sum is also required. For example, if we look at this, so what we will write one method to generate all the subset sum along with the length. Length means number of elements responsible to form that subset sum. Suppose here, let's say what our method will return something like this. If we see here, so if we pick 0 element, then what is the subset sum we get? We get 0, right? Which we like didn't pick any element. And if we pick one element, then what the subset sum we will get? 1, 2, right? And if we pick two element to form our subset, so what we will get? We need to pick this two only, right? We will get 3. So from left we get this, and from right same approach we will do. If we pick 0 element, then we will get 0. If we pick one element, then what is the subset we will get? We can pick only 3, so sum will be like this only, since we are picking only one element. And if we picked two elements to form the subset, then what we will get? One is 3, 4 we can pick, and that is 3, 5 we can pick, and that is 4, 5, 9 we can pick, right? This we can pick. And if we pick all the 3 elements here, so we need to pick all these 3 plus 4, 5. Sorry, 3 plus 4, 7 plus 5, 12. Right? So this we will get from the, this is one from the right part. We will write one method so that we will get something like this. And we need to also keep track of the number of elements responsible for that subset. So as we can know, many of us as now will think of hash map. Hash map is a good approach. We can create one hash map. And also there is a one more, we can use one array. Each bucket of that array, bucket or index of that array will store this in a list, this part in a list, right? Also we can use set here also, right? What I'm saying, we will get something like this. Suppose our method will return will something like this, right? This will be our length count. So if we get from left, let's suppose I'm looking at left part. So what we will get, no need of this box here. So delete this. For the left part, what we will get something like this: 0, 1. This is 0, 1. This is the left. So for 0, we will get something like 0. For 1, we will get something like 1, 2. And for 2, we will get something like 3, right? And for the right, from right, we will get 4 buckets or 4 indexes we want, right? So again, this will be 0, this will be 1, this will be 2, this will be 3. So we will get something like here again 0, and for 1 length is coming 3, 4, 5. For 2 we will get 7, 8, 9, and from 3, this is 9. From 3 we will get something like 12. So this how we will get this. One more thing we need to keep in mind while dividing this part, this original, like that array we have taken into 2 parts, we need to keep in how much indexes or buckets we need to create, right? Suppose our array was like this something, this, our array was something like 1, 2, 3, 4. In even case we can take this, in the even part we can take this, we can directly divide, right? So if our length here is n, which is 4, so if we divide by 2, so we will create one array of 2 size, and here we can create one array of 2 size, which will be fine. But suppose our array contain odd number of elements, 1, 2, 3, 4, and 5, odd number of elements. In that case, what we will get, 5 by 2, 2, right? So according to our, we are dividing equally, right? What when we create that array, we going to put some size here. So here we are putting n by 2 plus 1. This plus 1 also we will discuss why we are putting plus 1, but 5, 2. So if in the case of odd, if we can see right, left part is fine, but in the right part we got 3 elements, right? So if we put 2, 2 in each, then 2, 2 means half of in each, then this will not work, right? Because there are 3 numbers. There are 3 elements, right? So in this case, what we will do, for left part, n by 2 plus 1, and for right part, n minus n by 2 plus 1. So in that way, we will be safe from that array out of bound exception. So if we see for this case only 5 by 2, so what will be our length? Our length will be 0, 1, 2, 0, 1, 2, right? N by 2 plus 1, and from this side how much length we will create. N minus n by 2, 5 minus 2, 3 plus 1, 4, right? So 0, 1, 2, 3. Now why this one? Why not simply n by 2, right? So if we see here, when we create our buckets for like storing our subset sum, we are also picking 0, like 0th length, and also we are picking all the 3 elements right here. We can, sorry, we are picking all the 2 elements. And since in arrays like 0 size indexing, so we don't have this length, so we need to create one extra indexes for that. Let me explain. Suppose this is our array 1, 2, 3, 4 and 5. So in the left half we have taken this, in the right half we have taken this. So if we create array of only 2 size, this, suppose this, then 0, 1, in that case obviously we will get the of 0th length, we will get of 1 length subset sum. But what about these two? We can also pick these two also, right? So we will miss this, so that's why we need to create one extra for these two. So this will be 3, so that's why we keep n by 2 plus 1. Same logic from the right half also, we will do n minus n by 2 plus 1, because at the end we can also pick all 3 elements, right, to form our subset sum. So now the same example what we are discussing, we have got one array 1, 2, 3, 4, 5. So left we are creating something like this, 0, 1, 2, this is 0th, so 0, 1, 2. So of 0 length is 0, of 1 length it will be like 1, comma 2, comma 3. This will be in a list, we'll store it in a list. And for 2 length, this will be the left half and this will be the right half. This is right, this is left. 1 plus 2, 3, right? So from left we got this subset sum along with their indexes 0, 1, 2, and from right what we will get? We will get something like this, 0, 1, 2, 3. So this will be 0. Now 1 length will be 3, 4 and 5. Of 2 length it will be 3 plus 4, 7, 9, and for 3 length we need to pick everything 12 to form the subset. So this is, we got, this is of 0 length, this is of 1 length, this is of 2 length, this is of 3 length subset sum. That, so now our original problem was we need to find a subset A such that total sum, such that our the sum of that subset is equal to total sum into total number of count. Let's suppose this is left count and this is a total count. It should be equal. Now what we have done, we have divided it into 2 halves, the left half and right half, right, for easiness and for the complexity to reduce. Since we are like initially if we take all the like elements to generate the subset, then it will be 2 to the power n, but we have reduced this now. So one part we are generating 2 to the power n by 2, and the part we are generating 2 to the power n by 2, right? Now can we write this subset A will be equal to the sum, like the sum which we take from here, any sum which we take from here, left sum, left, suppose now left sum plus right sum equal to the total sum into left count plus right count. We can do like this, right? So left sum will be any of this sum. This is one of the left sum, this is another of the left sum, this is another left sum, this is another left sum, and these are right sum. 0, 3, 4, 5, these are the right subset sum. So we can write something like this: right sum equal to total sum into left count plus right count minus total count into left sum, right, total count. If we can write it, this is totally mathematics, we can write it down. So for each left sum we need to, now suppose this we have got till here, we have got one array, we have divided into two halves, left half and right half. Left half will contain elements 1, 2, right half will contain 3, 4, 5. We have formed all the subsets along with their count, subset sum along with their count. We have stored it in a list somewhere now, and also we have derived this formula: right sum should be equal to the total sum left count plus right count minus t into left count by t, left sum by t, right? So here what we need to do, let's suppose for length of 1, the length of 1 from the left we need to fix, and we need to find the corresponding right sum. What I'm trying to say is, suppose we have taken 1, right? So for this one we need to find the corresponding right here, and if that right exists in this part, then we have found one subset sum that average is equal to total sum, as we have derived earlier, this part total sum into number of left count right count upon total A. So main problem here is this: the right side of the count is not fixed, right? Because see, it's not necessary that we need to pick exactly n elements or exactly n by 2 elements. It's not given, right? We can pick any number of elements for subset sum A. We can pick apart from 0 and the total element. We should not pick 0, I mean none, and we should not pick all the elements, right? So for forming a subset sum A, either we can pick one element from here, we can pick two elements from here, we can pick three elements from here, or we can pick n minus 1, but we should not pick total element, or we should not pick 0 element. So what we did, we divide this into left and right, right? So for each, basically left and right is equal to this only, because that is the total sum. So if we picked one element, basically one element we have picked from left, then we need to find in all the right side element where this particular right is present, right? So what we will do, since already this formula is here, rs right sum equal to total sum, total count, I mean left count and right count, minus total count into left sum upon total count, right? This is a formula. So suppose we have picked this sum, we can calculate easily. We have picked 1 count, so we will try for all this right count. We will try for 0, we'll try for 1, we'll try for 2, we'll try for 3. Suppose we picked from here 2, and count is 2 here. Again total count we can easily get, and corresponding left sum. So we have picked, suppose here 2 from the, I mean for 1th count the sum is 2, and the total number of count. So we will get some right sum, right? We will get some right, and we need to And what the count we have picked for, right? We have picked 2 count, right? So 2 count is this array 798. So if we write it down here, 798. So this sum that we will get, we will search it here in this particular box. If we get it, then we will return true. Otherwise we will keep on searching. If not, then we will come out of the loop and we will return false. Right, so this is the whole concept of this problem. Now I will go to the tutorial show. So if you can see here, I have calculated here the total sum. This is the total sum, total number of length, right? As we have discussed here, we are making here one set, because see, finding in set is much more easier, right? If we store this in a set, this whole thing, instead of a list, if we store it in a set, then it is much more easier, right, to find something. We need to just find it exact values. If that exact value does not exist, then we will return it. So this will be basically a set. What I'm saying is this is will be an array, and each box will contain one set of subset sum, like this. So this is basically that part is n by 2 plus 1 n minus 2 by, this is the left set, this is the right set, and we are just initializing all those sets part. Now we are generating subset sum. As we have told, we will generate this part. So this method will generate my subset sum. Basically it will give me something like this for left and for right, stored in something like this. So I will get something, for example, this is my 0 index, this is my second, this is my true. So if we take for right part, so I will get something like this. Here this is empty for 0th, and if we see here for 1, I will get something 3, 4, 5. For 2, if I will get 7, 9, 8. This is 2 means we have taken 2 elements to form the subset sum. 3 means we have taken 3 elements from our array to form this subset sum, all the subset sums. So it will be 12. Only one subset sum is possible by taking 3 elements. So if we go to this method here, so this is my method. So I've taken start, end, nums, the array part, the count, and the cursor. So this is basically simple DP, I mean the backtracking approach to generate the subset sum. This, if we, like, obviously we all know, if we want to generate the subset sum, we have 2 possibilities, either to take that particular number or to not include that particular number. So this part is, we are excluding that particular number, we are just moving the start from start to start plus 1, and now count will remain same. Count is basically the number of elements, is the size of the subset sum we are counting, because we need size also, right? We need this size also. And this is the current sum. Obviously we have like skipped that element, so we will not add anything in this part. We are taking that particular element. Again, if we take that particular element, then obviously the size will increase, I mean the length of that subset will increase, and the sum will also like increase. Once we reach the end, this is base condition, we will add to that particular thing, and we will add the current sum, and we will let it from here. So with the help of this function, we will generate, if we can something like this, we will generate one left part and we will generate one right part. Now we will iterate for each of the left part, I mean left set dot length, left count. We will find the corresponding left sum, right? Basically what we are doing, we are iterating in these one by one. So this will be the left count, this will be the left count, and this we will get the left sum, right? So this will be the left sum, what we will get. So this we will get the left sum, and for that corresponding left sum we want the corresponding right. So we will iterate that left sum one by one. We will take one by one elements. So for example here, if we move here, so first we will take 3, then 4, then 5, and we will, for that particular left sum we have taken, we will search in all the right count, right? Because as we know, right count is not fixed, right? So we need to search in all. We don't know in which we need to search. Yeah, so we will search in all the right count here. We will iterate the right count one by one. We will, total count will be left count plus right count, and again this condition means, as this part of the conditions mean simply that we have discussed, we can't take all the elements in this part. We can't make that subset by taking all the elements or 0th element, right? This is what my LNR is, left count and right count, right? Because we are dividing our subset into two half, left half and right half, right? So this is total count, left count and right count. So if the total count is 0 or total count is n, means our subset should not be empty and our subset should not contain all the elements. These two conditions. Otherwise, if then we will not consider that. Another condition we need to check here, that this part, the above part, should be an integer, right? Why I am saying this should be an integer? Because see, if here if we see s into a by 2, as in our the main array we have all the integer number, right? 1 2 3 4 5, right? So the subset sum, the left sum should be an like integer, right? Not to here. Let's suppose this is our the main formula. So right sum is what? Right sum is basically, right sum is what? The, suppose this is the sum a that we are, right sum is what? Is basically the left sum and right sum only, right? And so right sum will be something like total sum of a minus left sum, right? So it should be in integer, right? It cannot come as a decimal, right? So it's just the original formula, and that if that is not an like integer, then we will like continue. Otherwise we will find the right part, and now we need to search that right should lie in that particular right count. Or like suppose we have taken left count as 1, corresponding left sum is 2, so we need to iterate in all the right count, and suppose we like end up at 2, so we need to search in 2 only, the corresponding right sum, right? So we will search in that particular right sum. If we find, then we return to, otherwise false.